Okay, well, let me, when you say, how do I get started in open source, I can go way, way back to when I started in 1969. I took a correspondence course in how to program the IBM 1130 in Fortran with cards, punch cards, right? And I read the book, and I happened to have access to an IBM 1130, and I practiced, and I had a couple people around who acted as mentors a little bit. And I was studying to be in electrical engineering at the time, but I kept doing less and less electrical engineering and more programming until finally I switched over, as a co-op student, I switched over to doing data processing. We didn't have computer science back then. We had data processing. We basically had computer black magic, okay?
Right.
And I studied a few courses and everything, but if I was to do it today, I think that I would look for a beginner's book on how to program in some language like Python or something like that. Or I could go out into the web and do a little searching for things like beginning Linux or beginning open source, and read the book and follow through and stuff like that. I might take a look around, if I'm in high school, I might take a look in high school to see if there's a computer club and start to hang out with those people and, start to use them as mentors to get started. If I'm at a university, do the same thing, okay? There's lots of meetup groups with people who have been, programming a long time, and you can meet up with them and say, hey, I'm just starting the beginning and I got some questions, or they might sit you down and help you to install Linux on your system. You could do it as a dual boot. You could do it as, running in a VM. You could, have a second disk on your system and boot off of that. You could even partition your disk enough to be able to have both of them on one disk, okay? So you can go back and forth. And another way I would get started in open source is I would start to use programs that run both on Windows or Mac, whatever you got, and Linux. So instead of using the Microsoft web browser, you might use Firefox. And Firefox is a really great browser, works on all the systems. You might say, let's use OpenOffice instead of using Microsoft Office. And you start to get used to that. And after a while, you might find out that there's hardly any or no programs that you actually use on Windows that don't run on Linux. And so after a while, you say, well, I can just now take out the Windows operating system and I can put in a Linux operating system. So these are some of the ways of getting started. I was a board chair for the Linux Professional Institute for a very long time. And we have certifications for people who want to do Linux and free software professionally. But for the people that aren't into that yet, we also have certificates that show you how to use Linux in your home environment or your office environment. And we have objectives. And you go down the list of objectives. If you say, well, yeah, I know how to do that. I know how to do that. Oh, geez, I don't even know what that is. Maybe I should study that a little bit. And teach yourself. And then at the end, if you want to, you don't have to, but if you want to, you could take a test and get a certificate that says, yeah, I know enough about Linux that I could use it in the office, right? And then you might find, if you're looking for a job, you might find that there are people who say, hey, can you use Linux? Because we're an open source shop. We try and use open source tools. And you can say, yeah, I can do that,
Sounds good. I want to ask, the hot topic now is GenAI. How is GenAI impacting open source from your perspective?
Well, quite frankly, I've been following AI ever since the 1970s, okay? And we go through a stage of expert systems, and expert systems are wonderful. I even wrote an expert system at one time to be a systems administration module. And I look at the LLMs as being kind of a super sophisticated expert system, okay, where it generates its own rules and you have its own data, it fills its own database. Oh, that's fine. But it's not cognitive. It doesn't really think, okay? And so when people talk about AI, I get all, I tend to like the term inorganic intelligence or whatever, and take them out of the thing of that. I also am a great fan of Isaac Asimov and the book I, Robot, and how it stepped through the very beginning of very simple robots all the way through to a robot that you couldn't even tell whether it was human or not. And all I have to say is that when it gets to the point where these things can actually think for themselves, I'm going to pull the plug.
Sounds good to me. All right. Yeah, no, it's getting advancing very quickly, very rapidly. Do you have any historical Linux open source free software moments that you want to share with the All Things Open community? A special moment in time or something that you don't want to be forgotten?
Well, so I was working for Digital Equipment Corporation from 1983 to 1999. And in November of 1993, I opened up this Dr. Dobbs Journal of Computer Calisthenics and Orthodontia, a magazine, and I saw listed a complete Unix system with all the source code for $99. And I knew that this was impossible because at the same time, the Unix Systems Labs was suing the butt off of IBSD for selling a system and all the source code for $1,000. And but it was only $99, so I sent away the money, and I got this little CD with a thin little book, but I couldn't run it because it used an Intel PC, and I didn't have any of those weak, miserable, crappy Intel PCs. I only had real workstations like VAXs and DEC Alphas and MIPS machines and stuff. So I mounted the CD, I looked at all of the man pages, said this looks pretty cool, and I put it in my filing cabinet. But we would just come out with the DEC Alpha, and it was the world's fastest microprocessor. For 8 years, we were in the Guinness Book of Records for having the fastest microprocessor in the world. We had a 64-bit address space, which is important because when you have 32 bits, you can look at 4 billion bytes of data at one time. But when you have 64 bits, you can look at 4 billion times 4 billion. So I'm going to ask your listeners to look down at the floor and imagine a 1 meter square piece of the floor, and that you can store 32,000 bytes of data on every square meter on the surface of the Earth, including all the oceans, in 64 bits.
Wow.
Yes. And what I wanted was an operating system that people could do research, computer research, in how to use very large address spaces more effectively. And in thinking through all the systems that existed in those days, there wasn't any that really had the ability of people doing that research to pass their data, to pass their code from one person to the other, so that everybody could collaborate on doing this research. There was Minix, but that was under its own licensing problems. There was, SCO Unix, but that was proprietary, and you had to have a $100,000 license to do that. So, about that time, I met Linus Torvalds, and I saw Linux for the first time, and I said, this is it. This is the thing that we would be able to, people could do computer science research. They didn't need to have any special license. And in fact, it encouraged people to redistribute their source code. So I asked Linus if he would do the port, and he did, and we helped him. And then I spent a lot of my time going around telling them, how great Linux was and how great free software was.
It's a great story. Thanks for sharing. Since we're here at All Things Open, I wanted to ask, do you have any tips, best practices, or new tools that you've been using to share with the All Things Open community?
Hey, this is Todd with All Things Open. Thank you so much for watching. We truly appreciate it. Also, be sure to subscribe to the channel and hit the notification button. We've got a lot of new content coming we think you're going to be interested in. One final favor, be sure to go to allthingsopen.org to see everything that we do. Back to the video.
Tips? Well, it's a kind of advice, okay? People ask me, what's the first programming language that I should learn? And people might think, oh, Python or Perl or something like that, but in reality, I believe it's shell programming, the shell script, because just as soon as you log into a Unix or Linux system, you're in shell. You don't have to load anything extra or anything else. There might be some slight differences between the shell, the Bourne shell, the corn shell, the C shell, and the bash shell, but they're minor. And you learn all the utilities and how to put together a shell script. And this is probably one of the most powerful things you can learn in your day-to-day programming to do that. And then after you've got the shell script down, go ahead and learn Python or some other language. But the next thing, and this will sound strange, I think you should learn some assembly language. And people say, well, John, nobody codes in assembly anymore. And I would be the first person I would be the last person to ever say code in assembly, okay? But you need to know how the machine actually works. You need to know how the registers work and how cache memory works and things like that, because you can write really abysmal code if you don't know that. And people will say, well, gee, that's what optimizing compilers are for, or that's why, or virtualization gets rid of that because, no, it does not. Even in a virtual machine, when you're actually executing the instructions, you're down there in the bare metal, and you really need to know how the machine is working. And in my career, I have taken programs that would run in 10.5 hours on a machine and make them run in 3 minutes. Same language, same operating system, same machine, but it's because I knew how the machine worked. And, you really need to know that. And people say, well, you don't need to know that because we have such big memories, we have all this power. And that's when I reach into my pocket and I pull out my phone. And for your people who are listening, I'm holding my phone up now. And I say, you need to know about performance because you want your battery to last longer than 15 minutes. And so you write your program, you may use some high-level language, you write your program, and then you tell the compiler to generate the instructions. You see how many instructions are generated, and then you see how long each instruction is going to take to execute, and you know how long that CPU is going to be working to execute that path. And if you can make that half its length, you've now shortened your program, and your battery's going to last longer. Or you're going to generate less heat, or you're going to, maybe Google doesn't need 10,000 servers in its data farm. Maybe it only needs 9,000 servers. Maybe it doesn't need a gigawatt of energy every hour. Maybe it can do with 900 megawatts of energy. All these things are efficiency, and people should learn those. Not right away. Okay, I understand that. You've got a lot of other stuff to learn. When I started in programming, locking the computer room door was security, and carrying the box of cards down the hallway was networking, and Snoopy on top of the doghouse in ASCII art was graphics. I understand that, okay? You've got a lot more stuff to worry about, but, when you've got that time, you're sitting on the toilet, and you say, what can I learn now? Oh, look, assembly language.
You were giving me flashbacks to college courses that where I learned that. So, all right, Maddog, I'm sure we could talk all day, but I want to make sure we can enjoy the conference as well. Any last parting words?
Well, it's been a while since I've been down here to one of Todd Lewis's events, but I do remember fondly when he started off in Charlotte, and I'm blown away by the number of people here and the questions that are being asked, and the number of people standing in front of the booths and asking people about their products and things. And so I say this is a great show, and I would encourage anybody if they're within earshot of this, and within we've got tomorrow, and I know that they're giving away some free leftover tickets and stuff, and come on down and see the event and talk with people. It's good.
Maddog, thanks for stopping by the We Love Open Source studio. We really appreciate it.
All right. Sure. Thank you.